Today we're taking a look at section 10.3 on permutations and combinations. We begin with permutations. Permutations are commonly called arrangements. So we may ask the question, how many permutations of n objects taken r at a time are there? Note that since we're talking about arrangements, order is important and repetitions are not allowed. When we are allowing repetitions, we must use the fundamental counting principle. So that's something very important. Let me highlight that. Okay, so again, to reiterate, when repetitions are allowed, we must use the fundamental counting principle. And we said with permutations, order is important. Alright, we have some different formulas here that we can use, and one that the textbook gives us is, this is read, permutations of n objects taken r at a time can be calculated by taking n times n minus 1 times n minus 2 all the way down to n minus r plus 1. So we start at n and we use r factors. So for example, permutations of 5 taken 2 at a time, we start at n, which is 5, and we'll have 2 factors, so we stop at 4. So 5 times 4 is 20. Permutations of 7 taken 3 at a time, we start at 7, and we'll have 3 factors, so 7, 6, and 5 give us 3 factors. Multiplying that out, we get 210. Permutations of 6 taken 6 at a time, we're going to start with 6, and we'll have 6 factors. So 1, 2, 3, 4, 5, 6, we get a product of 720. More commonly, this is the formula for permutations of n objects taken r at a time. N factorial over the difference between n and r factorial. So for example, if we're doing permutations of n objects taken 4 at a time, we would have n factorial, which in this case would be 9 factorial, over 9 minus the 4 factorial. So that's 9 factorial over 5 factorial. And notice the way I set this up. I go 9, 8, 7, 6, but then when I get to 5, I realize it's going to be the same as what I have in the denominator of 5 factorial. So those can be canceled, and then I just multiply 9 times 8 times 7 times 6. And that gives us 3024. Okay, and one last example here. Permutations of 10 taken 0 at a time would be 10 factorial over 10 minus 0, that factorial. 10 factorial over 10 factorial, all the factors cancel, and we just end up with 1. So, again, the important thing to remember about permutations, when should they be used? Order is important and repetitions are not allowed. Order is important, repetitions are not allowed. And again, if we have repetitions, we want to go back and use the fundamental counting principle. Okay, let's move on down to combinations. Combinations are commonly called subsets. Note that with the combinations, order is not important. It's very much like set theory, where we said the set containing 1, 2, and 3 is the same set as the set containing 3, 2, and 1. So order is not important. We're just looking which elements are gathered together in the group. And you'll notice that the formula for combinations is similar to the one for permutations. What it has is an added factor in the denominator of r factorial. So the number of combinations is going to be smaller than the number of permutations. So if we take combinations of 7 taken at 5 at a time, we have 7 factorial over 7 minus 5 factorial divided by, multiplied by 5 factorial, both in the denominator. So what I like to do is I take the larger of the 2 factorials in the denominator, and I'm going to stop with that in the numerator. So 7 times 6 times 5 factorial is going to cancel with the 5 factorial in the denominator. 2 factorial is just 2, so we have 7 times 6 divided by 2, which will give us 21. combinations of 10 taken 3 at a time. Again, we're going to put n factorial on top, that's 10. N minus r, 10 minus 3, that's factorial. And then a 3 factorial. So I have a 7 factorial and then a 3 factorial in the denominator. In the numerator, I'm going to take 10 times 9 times 8, and the larger of the two is the 7 factorial, so I'm going to stop there and cancel those. And of course this is going to give me a 6, so if we multiply and divide we get 120. Alright, so just to reiterate, when should combinations be used? Order is not important. Repetitions are not allowed. Now, the biggest problem I think students have is with selecting the correct counting method. So if the selected items can be repeated, we want to use the fundamental counting principle. If the selected items cannot be repeated and order is important, we use permutations. If the selected items cannot be repeated and order is not important, we use combinations. And then I have the instructions here for using the TI-8384 to evaluate some permutations and combinations. And let me open up my, let me just minimize this here. Got a lot of layers to go through. And let me get my Smart View. We'll kind of flip back and forth. I want to do a couple of these with the calculator to show you if you have a TI-83 or 84. Even an old 82, I believe, will work in this manner. Okay, over here to the left we have our calculator, and I'm going to clear it. And so let's see what our first one is. It's permutations of 10 taken 4 at a time. Okay, so what I'm going to do is I'm going to enter the 10, go to Math, then scroll across to Probability. Okay, and I want permutations. That's number 2. So I'm going to go down here and click on 2. Taken 4 at a time. And I enter. And we get 5,040. So let me go back and... Oops, let me get the pen. 5,040. Okay, now I'm going to do the next one. It's permutations of 30 taken 7 at a time. So let me clear this. I want 30, Math, and another way you can do this is go to the left. Permutations is number 2, taken, was it 10 at a time? I'm not sure. Okay, so notice this has gone into scientific notation, and it's saying it's 1.09, etc., times 10 to the 14th power. This is scientific notation, gives us a number that we multiply times 10 raised to the exponent at the very end. So that's equivalent to 1, okay, I'm going to have to go back on the other, 1.09, I'm just going to call it, oops, it was supposed to be 7. Let me go back and correct that. Alright, clear. 30, Math, Probability, Permutations, 7. Okay, so it's going to be 1.0, I'm just going to say 1.03 times 10 to the 10th. Notice basically what that's saying is we're going to have to move the decimal point 10 places, and we can tell it's to the right because it's positive. Okay, combinations of 25 taken 6 at a time. Let's see if I can remember the two numbers this time. Alright, 25. I want to go to Math, Probability. We want combinations, and I believe it was 6. And so we get 177,100. And we have one last one, combinations of 36 taken 2 at a time. 36, whoops, backspace, okay, and I want to delete that. Alright, math, probability, combinations is 3, 2 at a time. Oops, again, I got one extra in there. Delete, okay. Alright, I got 630. So you can see if you do have a TI-83 or 84 calculator, it's fairly easy to do those. The main thing is to recognize this is the key that you have to use. Many other scientific calculators have permutations, combinations, and also factorials. So what you want to do is check out your calculator and read the instruction book if you don't have a TI-83, 84. And I believe that's it on this particular lesson.